Hello, class. How y'all doing?
All right.
All right, all right. Yeah, I took my test. Hello?
Yes, sir.
All right. All right. We starting on chapter 4, right?
Yes, sir.
Yes.
All right. Anybody with any questions, any whatever concern?
No, sir.
No, sir.
I know some people sent me emails about the program. They want extensions. Y'all still need extensions on the program? Hello?
I mean, if somebody else needs it, I mean, sure.
I don't hear them, no. I don't hear nobody saying nothing. So it's straight? Everybody straight? I know some people reached out and
I know one of them isn't in here.
huh?
I know one of the people that probably needs an
Oh,
extension
they're not
isn't
in
in
the
here.
I see what
Yeah,
you're saying.
'cause
Yeah.
he messaged me too. So
Right.
Well, I know I have some, Professor.
Huh? What about, yeah, you can use it. What's that now? That's Mr. Booker.
Yes, sir.
What's up? What you got?
I got some help. So I did them I got it straight except for like one program.
Which
I
one?
The one with the numbers at the end. I got everything, but at the end of it where it said when you put in it's supposed to read in your numbers. I got the part where it said if it's an even number, it'll say even, but I couldn't get the numbers and stuff, like the numbers that I programmed, the 3 numbers that I use.
That you use to be printed out?
Yes, sir. At the in there where it said at the end, if it displays the 3 numbers and it gives the total and then it gives the enter. It was just the 3 numbers I couldn't fit. I got the part where it say if it's even or odd, but I couldn't get the numbers in the program itself at the bottom. On the line.
Yeah. You did. Was that you? I know it was somebody I talked to. I told him to look back at the video.
No.
Most times, like I say, I will not tell you what to do, but I'll direct you.
Yeah.
Because I think somebody had asked me a question about something, and I directed them to. Then they say, "How you do that?" So, and I didn't respond because you know what I'm saying. I'm not gonna tell you how to, but I'll lead you to where. And for your point, say here we got 3 numbers, right? I'll say equal x plus y plus z. Okay. All right. So if I wanted to print out something like 2 plus 3 plus 8 equals and whatever the total is, right? But I don't want to print out the string 2 plus 3 plus 8. I want to print out those values, correct?
Yes, sir.
What I would do is this. I would do something like C out, and then I would, I'm gonna just do a space, a tab, all right? But that's just a tab, but you just stream whatever, and I'll say X, you understand? And then I'll stream whatever I'm streaming, space plus. So that's gonna put out whatever the value for X is, because see here, not in double quotes. You see that, right? X, then I'm a string, space plus space. Then I'm a stream Y, whatever the value for Y is. Then I'm a stream space plus space. And like I say, yours said something like the product of, and then it'll be X and Y and whatever is whatever. So yours was in the same, same format of this. and then I'll stream Z, and then stream Z, and then stream equals, and then I can stream total or tote. Now, so you want to see what this look like, right?
Yes, sir.
So when I run this, I can go back. Okay. When I run this, I'll do a debug. I think I got everything commented on. See?
Okay.
It tabbed over. That's this. Stream X, which is 2. Stream space plus space. Stream Y, which is 3. Stream space plus space. Stream Z, which is 8. Stream space equals space. Stream tote, which is 13.
Okay.
So you see, you're controlling it by streaming text, but then you're streaming the value. Stream the text, stream the variable, which is going to be the value.
Okay.
Yeah, you got it?
Okay. Okay.
Because like I said, that's how you can, like, I don't know, I think you all did the program. Well, I had a paragraph. My name, well, hello, whoever. My name is, and then the name. I'm enrolled in BRCC in whatever, fall 2000, whatever. My major is whatever major. I plan to work in whatever area. So that's how you was able to manipulate that paragraph by putting out the string and then writing out the putting out the variable, which would be the value of that variable.
Okay.
You got, so like this would be like test 1. Well, this would have been score 1, and then no, that's not the score. That's dealing with, you did it with what was the product? I was dealing with product.
Yes,
right,
sir.
Right. So like this would be, and like all I had to do is add here. Watch. Or not, I'll say sum. And I can say product, sum, whatever, but it just said, I'll say A and you understand what I'm saying? I just put words in there and debug it and look. I say show up. See, the sum of 2 and 3 and 8 is, I didn't have my space in. So you got me? It's like, right. That's like kind of dressing it up, you know, how the user want it, you know, but that's why you got to kind of understand programming, because the user might want something in a certain way. And if you know program, you know how to put it, you know, just how they want it, right? It might not always just want the answer. Yeah. So see, yeah. So that's all that was. You manipulating this, but well, I gave you how I wanted it to look, and all you had to do is write it out in the C++ statement. You got to remember though, whatever I'm streaming, I'm gonna stream some text. Okay, if I'm gonna stream some more text, and I want it different, I have to, and I'm in the double quotes, I have to do another stream. I'm streaming a value, streaming text, streaming value or string, streaming value, streaming a string. Streaming value, streaming a string, streaming value. You know what I'm saying? And then ending. Okay?
Okay.
Yeah. Because like I say, what some people would try to do, they'll try to do this. Sum of 2 plus, if I could type, which would give you the exact same thing, but it's not right. Plus 3 plus 8 equals, is, I can say equal. All right, they'll do something like this. And if I debug it, it's gonna give you output. Oh, I gotta show you. All right, so it's gonna give you the output, but what happens is when I change these numbers here, then you'd have to go inside this display area here and change these numbers here. So that's not what you want to do. All right. You try to make your program as flexible as possible. And let me, if I click in here, let me undo and show you what I'm talking about. Okay. All right. So see this. Now, if I could just go in here and change these numbers. I'll change this to 12, 31, and 18. But when I run the program, I don't have to mess with any of this. I'll run it. Should come up. See what I'm saying? It automatically put the 12, the 31, the 18, and sum them up. Got my answer. But if you try to put everything in the string in here, whenever you change this, you're gonna have to change this, or your label gonna be off. All right. You got it?
Yes, sir.
Okay. Anybody else? If they need more time on the program, nobody said nothing about that, so I guess we just could move on.
I could.
Okay, which one?
And just
The
so I
last
can
one?
go back in and redo that one and submit it.
At the last one? Oh no, that's not the last one. Which one that was?
was,
The product.
Yeah, okay, let's see. What number program? Program. I guess I could find it. Let's see. Program 3. Oh, 4. No, 4. It wasn't 4. It wasn't 4.
Program 1.
Oh, 1? Oh,
1,
okay.
yes, sir.
All right, let's look at this.
Wait, no, that's not it.
No, and like I said, on this one, you had to make sure you had what? 1 decimal for all these and 2 decimals for the last one. Remember?
Let me see.
Yeah. I'm gonna go to the next one.
On the paper, it's saying no, wasn't that one.
That's 2.
Uh-huh.
This 3. So it had to be the 4th one.
I
No.
think it's chapter
No.
3 program.
Those different.
Oh, I'm on chapter 4. Okay, all right, okay. Yeah, I'm in chapter 4. Yeah, I got y'all in chapter 4. Okay, chapter 3.
Hey, Professor.
Yeah.
Also, could you add an extension on let me see something real quick. On program 3 and 2, please.
Okay. All right. Okay, yeah, this is the wait, this is the average. That's good. Wait, that's all right. Oh, I think when I did, I went forward. Okay, let's see some. That's 3. That's 2. Okay, now this one you have to have the same set W. Somebody they tried to space it out. And I told them set W for the heading, column heading, and also the same set W's for each one of these columns. All of these was 2 decimal except this one. This one was 1 decimal place. So you have to remember that. Previous, let's see. Yeah, this is the one.
That's it. That's it.
Yeah, it's program 1, you're right. And see, I just put question marks here, and it's a comma. You know, it's a comma. And like I say, all you have to do is stream, the comma space, well, not a space after a comma, just comma space, this, then space and space, whatever, then space is space, and then the value. All right? All right. And
The even and odd thing on this one right here. It had me confused for a little. I think I figured it out. I'm not sure if I did it. If there's like a better way to do it.
All right. Well, with that one, all it was is a form. There's many different ways people do it. One way is you can say, okay, let's take take X, all right? So what you could say, if X mod, oh, I'm gonna type mod, what percent? Mod 2 is equal to 0, not 2. Yeah, X mod 2 is equal to 0. Then you know num even. I'm gonna just do see out number even. All right. Otherwise, else, let's see, yeah. Else, so because what happens is, X mod, well, 12 mod 2 is what? Modulus 2 is what?
0.
0, no remainder. All right. 31 modulus 2 is what?
1.
1, because I was say 2 going to that, what, 15 times with 1 remainder. So when I do any number, mod 2 is going to return an int value. And like I said, if it doesn't divide equally, it's going to be a number remainder. But if it does divide by 2 evenly, it's going to be even. So when I run this, it's going to say even. All right. It's going to say num even. Oh, got an arrow. What arrow? Oh, let's see. Oh, semicolon. All right. All right, they're gonna say num even. See up here, you can't see it up here. Num even. All right. So if I we'll put this that's why I put them spaces in it so you can see the output. That's the only reason. So now if I change this to Y, we know that Y is 31, so Y is gonna make this output odd. See, numbers odd. All right. So
Okay.
now, huh?
Oh, that's how I did it with the
Right.
if and the modulus 2 equals 0. I just
Now,
wanted to
right. Okay. Now another way you could do it is make sure that your variable is integer. Okay. Then if you say x divided by 2 times 2, you understand what I'm saying? So a number, integer divided by 2, like say 31 divided by 2 is what? 15, right?
15 and a half, right?
Well, integer, right?
Oh, it
If
would
it's
come out as
integer,
15.
31 divided by 2 is what?
It would come out as 15 as an integer, right?
All right, times 2.
30.
All right. And then so you asking if this is equal to x. You understand what I'm saying?
Oh, okay, I see.
Right. So if that number don't return back to be the same, right? Let's see, how that was. If x, let's see.
I kind of like that one. That's clever.
Yeah, there you go. Huh?
I was
If
just saying, I
what?
kind of like that one. That's clever.
Oh, this one, yeah, it's like a little mind twister, yeah. Right. But like I say, you got to make sure it's integer, because if I do 2.0 and make all this float, then I'll get the same number that I tried to divide by. So you got to be thinking. Right.
Yeah, so it's kind of just taking advantage of the problem with the integer. Okay.
With the integer, that's what I was telling you. Sometimes you want to use int for a particular value. Not always, you don't always want to set something to float, to try to get a precise number. Sometimes you want to use it, and take advantage of that. All right. So, like I say, that's how those programs work. All right.
There was one more thing I wanted to ask about.
What's that?
So I've been including all of the includes in the header file. Is it do we get points off if we include things that we don't necessarily need?
No, I don't take off for that. Nah.
Okay. Does that technically make the program slower or less efficient?
When you're dealing on a larger scale, yes. Because
Okay.
what happens as you load those libraries, you're giving the program more file, more things to execute or hold. You understand? Which
Right.
makes the program larger, which makes there more code, which makes it a little slower. But like I say, these programs are so small, you can't really even tell. You know what I'm saying? You can't tell. You know,
So it's just best practice to use what
right. Just use what you need. Right. That's right. Yep. Yep. That's right. Yep. Yeah. Any other questions? Let me add those programs before I go. Well, I tell you what, I'm gonna add them. I'm gonna open them at the end of class because some people gonna want to work on them while class going on. So I'll hold off on that one. Any other questions?
Professor, would you like to go over program 2? And also, did you say you were extending program 1? I'm speaking for the people in chat that don't have mics.
Yeah, I'm gonna do them all. I'm gonna do them. Yeah, and me in that chat, I'm gonna say my screen. You know what I'm saying. I got you the display of people on it, but I don't have everybody. Just a list. Then I got the bar at the bottom with you know the video mute security.
Yeah.
So if I add that, then I'm taking away screen. And then it's like I gotta shift and move around and
Yeah,
so,
you're good. You're good. You're good. I got you. I'm speaking for him.
all right, okay, all right, yeah. They're not that I don't want to talk to them through chat, you know, just that's
No, understandable,
that's
Professor. You're fine, man. You're fine.
right. But yeah, what I'll do, I'll add those other well, all three of them. I'll just add a couple of days to all three of them so they can have some time to do them, you know,
Yes,
do the
sir.
program.
Thank
But
you
like I
for
said,
that.
and remind me after class, because like I said, if I add them now, they're not gonna pay attention to the class and they're gonna be doing the work. And by the time they finish that, they'll be lost with whatever this is.
Yeah,
So,
I got you. I'll remind you at the end, Professor.
all right. Okay.
Thank you.
You're welcome. All right. So chapter 4, now we are dealing with if logic. All right. Before we've just dealt with, you know, just writing statement after statement after statement after statement, which is sequential. All right. Now we're dealing with the if logic. All right, making a decisions and branching off to different parts of the code and executing it and returning back to the program. All right. So it starts off talking about these relational operators. In math, you have, well, these relational operators, if you took math, you know that these are similar, all of the ones at the top. The last two we'll go over. Greater than, always to the right. Less than, points to the left. Greater than or equal to, that's what this is. Less than or equal to. Now, you wouldn't do equal greater than. That's another symbol, that you know, so you don't use it. It's greater than or equal to. Less than or equal to. Now, these two down here, the equal, that's a relational operator. It's not the equal. All right, and I'll show you how some people mess up with that. The exclamation point equal, that's not equal. Anytime you see this exclamation point, whether it's in code or whatever, related to the, well, yeah, if it's with the code, related with the not. If it's just in a string, well, that's something different. That's just a string. But the not equal. They got not in no file. You could do not amount. All right. So like I say, that means if it's 0, not amount. So you can do things like that with the not symbol. All right. But you got your regular mathematical symbols that's used as operators, but then you have the equal, which is a relational equal, and then the not. All right. So, like I said, if you take a math, x greater than y, x less than y. X greater than or equal to Y, X less than or equal to Y, X equals Y, X not equals Y. Okay, so that's how they're used. And like I said, I'm just skipping through this and basically just telling you the same thing. Now, look at this. This is really checking or comparing A to 4. Let's look at it in a program to give you a better understanding. All right. If I do this, okay, and I'll say is, and I'll just say, okay, is equal, is going to print here, not equal. So if I do something like this, if X 12, right? So X is equal to 12 here. So if we ask if X equal 12, what is going to output? It's going to output what, class? Is equal, correct? So when I debug this, what happened? I had it open. I need to close it. Close that window, not running. All right. So is equal. So I get is equal. But watch this. If I do something like this, right, I should still get what? I will still get what? Is equal. Okay, I'm gonna close this out. And I'll run it so you could see. Is equal. Everybody see that? But if I do something like this, what should print out, class?
Not equal.
Okay. Mr. Booker said not equal. Somebody else said not equal. What? Look at this statement. What this statement saying? Right here. Tell me what this statement saying.
If X equals 12,
But what is it doing in here?
it's wait,
What's going on right here?
Is it making X 12 right
12.
It's making X 12, which when I ask the question, is it 12? What is it going to be?
there? It's going to be 12.
Which going to make it what?
12.
Equal,
Yeah.
right?
Okay.
So no matter what I do outside of this, if I use just that single equal, I'm not comparing it anymore. I'm assigning it that value and running it that way. So watch what happens. Yeah, I should get what? Is equal, which we know is not. You see what I'm saying? Because what we did, we assigned X to be 2,000, but then right here we said, okay, if, and we assign X equal 12. If I assign it to equal 12, then it is what?
12.
Equal 12. So that's some of the things you got to watch when you're dealing with these logical operators. You got to make sure if you're going to compare something, you have to use what? The double equal. Now just check. I'm gonna run it again. I'm gonna close this one out first. I'm gonna run it again and watch what happens. See, not equal, because this time we compared it. We didn't assign it. Everybody got that? Right? Okay. Now, another problem that students have, and I like to show you these issues because sometimes, just sometimes, you writing code and you don't get a syntax error, and you're wondering what's going on. What I'm gonna do, I'm gonna comment this out, so I'm gonna just have an if statement. Okay. So what this saying is, I'm just checking to see if if X is equal to 12, and then what? If not, I'm just gonna end the program. But if it is equal, I'm gonna write out is equal. Everybody understand that? I just took the else condition, which is like the default condition. If it's true, do this. If it's false, do this. But right now, I don't have a false condition. Is if it's true, do this, and then otherwise continue on with the program. But watch this. What some students do is this. And that's a major, major, major mistake. If you put a semicolon at the end of that if, you just said, okay, this is all I want to do on that line. Now continue on with the program. Okay, so if I run this program, if I say I'm going to assign X to 12, it's going to say, okay, if X is equal to 12, it's not going to even check this. It's just going to say, okay, I'm ending my if, now perform the rest. So it's going to print out what? Is equal. All right. So everybody see what just happened. Everybody see what just happened. No matter what I did, no matter what's going on here, this thing says do this if statement and then finish it. You finished. Open bracket, close bracket, that don't matter. Hey, I'm finished with my if, now continue on with my program. So don't do this. Don't ever put a semicolon at the end of your if you wanted to perform that true logic. All right. Like I say, you perform that true logic only if this is equal. Right. Now watch when I run it without that. I just won't get anything because I don't have an else logic. Because 2012 is not equal to 2000. Oh, where is it? Yeah. See, I didn't get anything. Let me run it again. I'll just debug it again. And I won't get any output, see? Because what happened? 2000, X is equal to 2000. If X is equal to 12, output this. Oh, it's not equal to 12. Return 0, I'm finished. Okay? So those are some of the do's and don'ts and things to watch out for with if statements. So let's look at if statements and how they actually work. Okay. So we get back here, that's a sign in or whatever. All right, greater than or equal to A. Let A greater than or equal to C. So all it's doing is checking to see if B is greater than or equal to A, then if A is greater than or equal to C. All right. This asks if A is greater than or equal to 5, and they gave values here. 6 greater than, now, this is another thing I want to let you know, and some students run into that issue. Greater than, my fault. And make this 12. Now, I don't want to say equal or say, and I'll take this off. And I just put some just output so we know where we're at. And I'll put all right. So we got the output here and there. So looking at this, if X is greater than 12, output here, else output there. What will it output, class?
There.
Huh?
There.
There.
There, not here, because 12 is not equal. I mean, 12 is not greater than 12. 12 is equal to 12, but it's not greater than. And sometimes students get confused with that. So you gotta be careful. You gotta understand this is exclusive. 12 is not a part of this this expression here. So if X is greater than 12, all right. No, it's not. So you're gonna do it's gonna output there. All right. So when we look at it, oh yeah, see there. So only if I do this, if I say this now, oh no, I told you can't do that. If I do this, now if X is what? Greater than or equal to, now you included the what? 12 on. Everybody understand that? Now you've included 12 and anything greater than 12. But the first one, when they had greater than, 12 was excluded out of that range. Everybody got that? So you got to be careful when you're looking at using that greater than symbol, or even less than, because what? Well, I'm gonna do greater than or equal to, and so let you see what the output is. Now, if I do that, it's gonna print out here. So when I do this, when I debug it this time, it's gonna print out here because 12 is a part of that range. See, it printed out here. All right. Everybody see that? Now, and like I said, the same holds true for less than. 12 is not less than 12. 12 is equal to 12. So if I run this, it's going to print there. All right. If I debug it, it's going to print there. Okay. See, sometimes you got to rerun the program for some reason. Okay, so I run it. It's going to print there. Okay. Hit enter. But then if I what? If I say less than or equal to, all of a sudden now 12 is included in that range, and now it will print here. All right. All right, here. And like I said, that's very, very important when you start writing code. And if somebody say, well, if test score is greater than 50, do such and such. Now, and somebody put greater than or equal to, then what happens? That code is written wrong because what? Now you've included all of scores of 50 and above, and the 50 shouldn't have been included. So that makes your code, wrong. Your algorithm is actually wrong. All right. So you got to be mindful of that. So, and like I said, they're not equal. That means they're not the same. All right. All right. They're not the same. And like I say here, we give you the same thing. X less than Y, but they give you X is 10. Is 10 less than 7? No, false. If 10 greater than 7, yes. Is 10 greater than or equal to 7? Yes. Is 10 less than or equal to 7? No. Is 10 not equal, or is 7 not equal to 10? True. You understand? So you got a not equal. Is 10 not, or 7 not equal 10? True. All right. And it'll perform the true logic. All right. Okay. So now it says what is true. All right. All right. It says what is true. All right. Is one would expect to find in a philosophy book, but like I said, you're gonna be using it in computer science, not in C++ programming text. All right. It is a good question for us to consider though. If a relational expression can be either true or false, how are those values represented internally in a program? By 1 and 0. That's how they represent it. If something is true, the program yields 1. If it's false, the program yields 0. You got to keep that in mind. All right. So if you look at this small program here. So what happens? They set some Boolean values, some bool values of true value and false value. So these values can only equal to 1 or 0. All right, 2 values, 1 or 0. They say X is equal to 5, Y is equal to 10. Now, look what they did. They say true value is equal to X less than Y. But you're saying, okay, what you mean is equal to X less than Y? It means that it's going to evaluate whether or not X is less than Y. If it's true, it's going to assign 1 to true value. If X less than Y is false, it's going to assign 0 to true value. If Y, then you got Y equal X, false value equal Y equal X. So, and notice, this Y is assigning whatever this evaluates to. This equal, is assigning a value to it, whatever this expression yields. This equal is comparing whether or not Y is equal to X. All right. And like I say, if it's equal, you're going to get a 1 or 0, which will be then in turn assigned to false value. So look what happens. What did this say? 5 and 10. 5 less than 10. That's false. Wait, yeah, 5 mean it's true. So true value, all right? True is true value. So true value, and it printed out what? The 1, true value. False is y equals x. No, 5 is not equal to 10. So it's like this yield to be false, and false value holds the value of 0. So you see how an expression is evaluated, even in an if statement, and then when we get to the next chapter, even in a while statement, it looks at that expression, evaluates it, and returns a 0 or a 1, whether it's true or it's false. All right, 1 or 0. All right. So all it's doing is telling you how it got the values here. All right. It says relational expressions have a higher precedence than the assignment operator. So what that means, it's going to solve this first, and then it's going to assign. That's all it says. That's all that means by the higher precedence. It will perform this action, x less than y first, and once it gets the value, then it's going to assign because this precedence is lower. All right. So look at this. This gives some examples. It says z is equal to, now what's happening here? We what? Solving this and assigning the value. If x is 10 and y is 7, x less than y, no, that'll be 0 because it's going to store a 0 into z. We're looking at this one, C out. Now look what happens here. We're not assigning the relational value. We actually outputting it. And like I say, we could do it ourselves. We could say, rather than an if statement here, we'll do it this, we could take this out. And we could just say, C out, I'll just do this and then do stream the results of any one of them. I could say y not equal to 50. So what? What? Y not equal to 50. Y is equal to 31. Is 31 not equal to 50? That's true. You understand? So that's true. So what? It's going to print results and the number what? 1. So when we debug this, it's going to print out results and a 1 because y is not equal to. Everybody see that, right? It printed out that result of that expression. Okay. All right. Now, this one is solving for this and then assigning to A. This again, solving this expression and then assigning the expression value to this. All right. This here solving the expression assigning, or this output and assigning. All right. All right. So that's what happens there. So let's look at the if statement. And we kind of looked at it already in the program. But it says the if statement can cause other statements to execute only under certain conditions. And we saw that when we had the program. What? I'm going to undo if I can. Yeah. So only under certain conditions will this statement run and on this statement. So if x is less than 12, it's going to perform this. Otherwise, it's going to perform this. All right. And watch out, I'll do this so you can see some too. And now, so looking at this, okay, it will, if X is less than 12, it will perform this statement here, all right? Because what? It's going to return a 1, it's going to perform the true logic. But if X is not less than 12, it's going to perform the false logic. But regardless of these, it will always perform this because this is outside of that if logic. So if this is true, it's going to perform this and then perform end of program. If it's false, it's going to perform this and do end of program. Because end of program is not a part of this if logic. If I took this statement and put inside of this, then it will only print out end of program if they print out there, if it's false logic. So let's run it, okay? X is not less than 12, so it's gonna print out there, then it's gonna print out this after it gets out, exit out of the if statement, all right? See, there, and then end of program, okay? Because what? It checked to see if it's gonna print out this or this. Once it did determine which one is gonna print, it exit out and then continue with the program. So now this was the statement that it had to execute. All right. So any questions so far? Any questions? Questions? All right. So this is talking about what we've previously been doing. We've been writing code in a sequence structure before, where it's statement after statement after statement after statement after statement. But all of a sudden now we're going to be branching off. We're going to be doing a decision. So like I say, depending on if it's this, we performing this, then we coming back into the program. All right. So in decision structure, okay, simplest form, a specific action is taken only if a specific condition exists. Okay. If the condition doesn't exist, the action is not performed. That's only if you have a if X is greater than 5, do this, then continue on with the program. All right. But then, like I said, you can have an if else. If it's true, do this, else do that. All right. And they just running you through the program, the step by steps. All right, which was sequence. But now look here. If it is cold outside, if it is, get a coat and then fall back into logic and do whatever it may be. Get your books, get your whatever, and start your car and go to school. If it's cold, if it's false, then what? I don't need the coat, so I could get my books, get my coat, get my books, start the car, go to school. So that's what if logic does. It allows you to branch off, execute, and then fall back into the logic of the program. All right. So look at this. You could also have a sequence structure embedded within the if logic. So what? In a sequence, what I say, that just step after step after step instruction. And this would be what? You're branching off a decision. So it's like, if it's cold outside, if it is, get the coat, get the hat, get the gloves. All right. And then what? Fall back into the code and finish execute. All right. So you can build on programs and logic in anywhere. But like I say, that logic can be considered to be sequential, can be decision, or it can be loop, all right, which we're going to get in the next chapter, all right? So let's look at this program. What they're doing, they're setting a high score of 95, a constant value. Then they have 3 test scores and then an average. So what happens is they're allowing the user to input 3 test scores. Score 1, score 2, score 3. Then they're calculating the average, all right, by adding the scores collectively and dividing by 3 and assigning it into the variable average. Once that's done, they're setting they are decimal point of their output. So what they did show point. When you do show point, set precision. Now, any output that's of decimal form gonna have only what? 1 decimal place, all right? So all of a sudden now you have your average is and whatever average. And whatever that average is, even if it's a whole number, it's going to print out with a decimal place. All right. But they didn't stop there. They found the average, but then what? If average greater than high score, what's high score? High score was a constant of 95. So whatever you calculate the average to be, if that average was greater than 95, now look, it didn't say greater than or equal to, right, class? It didn't say greater than or equal to. It said greater than. So everybody who made a 96, 97, 98, 99, and 100, they're the only ones who will get this prompt or this output. Congratulations. Congratulations. Thanks. I mean, that's a high score, right? 95 is not included. Okay. So that's all this program does. And look at this. Now, the only thing I would tell you about this code here is that they didn't group the body of the if statement with open and close curly braces. It's not a problem if you have only one statement. It becomes a problem when you have multiple statements. Now you might say, well, what do you mean, Mrs. Vessel? All right, this is what I mean. Let's look at this code here. So we have what I'll do, I'll take this off. I'll comment it out again. I'll comment here. All right, so I commented this part out, so I'll move that down. So if X is less than 12, I want to do this, okay? Now, so I'll take this off. That's a good program. That will run, all right? All right, if it's less than 12, it's gonna print that, otherwise it's gonna come out here and print this and finish, all right? So let's run this. I don't know why it's getting the errors. I think I got it straight. Debug. All right, so see what happened. Look, program ended. So what happened? It says, okay, if X less than 12, no, it's not. Program is ended. So let's say we do less than or equal to. Okay, we forcing it to print out this output here, here, and then this. So let's debug it. Oh man. All right. So we run it, and now it's gonna print out here, and then program has in it. Oh, I gotta. All right. So see, here, and program has in it. Because what? It's less than or equal to. Now, watch this though. If I said, okay, if it's less than 12, I want to print out here, but I also want to print out I want to print out that, all right? Let's see. All right. So I want to print out this and this. So what's going to happen? It's going to print. It will print them both, but by default. Watch. Oh, no semicolon. My fault. All right. All right. So let's run this. Debug. See? Okay. So look here. X less than 12. Right? It was less than. So you're saying, man, look, my program is working. Oh, I'm straight. Watch what happens here. What happened? Oh, and I told y'all I can't do that. You got to do the greater than or equal, not equal greater than. All right, so let me debug it. All right. So it printed out here, and X is greater than 12, right? But I still don't want it. That's not what I want. Okay. Right, right. Why did they hear X greater than 12? Wait a minute, wait a minute, wait a minute. Right. But see what's happening is it's printing out both of these regardless, but it say less than 12. Oh man, why? Why did I do that? But this is what I really want to do. I only want to print out this information, all right? If it's less than, all right? So I changed this to less than 12, all right? Oh, I see what I didn't do. Let me take this off. I did an equal sign. So I'll do, say X greater than 12. All right, I did the equal sign. So if it's greater than 12, that's false, right? But I have by default, it's gonna do that one statement, but then it's gonna do the next one. Why? Watch this, and I'll explain to you. Wait. All right, so look what happens here. It didn't print here, but it did still print what? X is less than 12. You got what I'm saying? Now, if I wanted these two to be together, all right, I have to group them in this fashion. You understand? Now what? If I run this, oh, what did I do? All right, if I run this, it's just gonna say what? End of program, if I can show you. Yeah, see? End of program. Because what? If it's greater than 12, I wanna do both of these, you know? I wanna do both of these. So that's why it becomes important to have those curly braces, because when you start adding code and you want that code to be associated with this if statement, and it's not embodied in the curly braces, it can throw your logic way off. And you wonder, I'm not getting any errors. It's giving me this, but I know what the values I'm putting in. So you got to be able to, and that's why I say, just put the curly braces. And if you ever have to add whatever, add 10 statements, 15 different statements, you know you have your body for your if logic. You know if this holds true, this is what I want to do, and you're straight. Otherwise, you might forget, and you have something like this, and then you got that one statement is going to do or not do, and then it's going to still do all the other statements, and you're wondering like, man, what's going on? Why am my program doing this? All right. So you got to be mindful of the embodiment of your code that you're going to execute. But like I say, it's not an error. That's not an error. If you look at this, when you have if this is this, if it's only one statement, there's no problem. But I'll just say put the curly braces just to be on the safe side. Okay? So, and look at this. This is the flow chart of this. If average is greater than high score, which is 95, we print out, we go in here. Class, what is wrong with this right here? Who can tell me what's wrong with this diagram? Anybody? Can anybody tell me what's wrong with this? And we're talking about flow charts.
It would print out the quotes as well.
No. Look at this. I'm talking about symbol wise. Dealing with symbols. Who could tell me the problem? What symbol is the input-output symbol? I might have it here, then I might not. Remember the parallelogram? The diagonal box, that's the symbol for outputting data, and they got display, and what they're doing, they got it as a process, and it's not a process, right? This should be that line going from here to here, going from here to here on a diagonal, not a rectangle. So that's a misprint in the book. All right. So now look at this. If hours greater than 40, do this. Overtime is equal to true. All right. If value greater than 30, see out invalid number. If overtime equals true, all right. So look at this. If overtime equals true, remember what I told you? What this statement does, this checks to see if overtime is equal to 0. If it's equal to 0, then it's false. Any other number makes it true. All right. So if you write in code and you want to check to see if a number has a value, you can say if number equals true or whatever it is, and it should return whatever. So watch. I'll just do this. If X equals true. All right. All right. So see how that true was a well, it should have been true. Oh, X gotta be I can't use, yeah, I can use X. Can I use X? No, I have to assign X to a value. But I done it one. I could do this. If X, I could do that. Or I could do if not X. That means if it's not X. This means if it's X, I should do it. Yeah, if X, that means and X is 12, and it'll print out here. So let's run it. And it should say print out here. See, it printed out here. But now why? If I say not X, that means if it's 0, it's gonna skip this and it's gonna print this. And it should skip to here because it is true, you see. So you can check to see if a number is whatever. But what they did, they assigned it to a value and then check the value of the variable. They'll assign it to a variable. But that means if not X, all right? If X don't have if X is 0, because watch if I do this, all right? If not X, that's gonna be true. So it gonna print out here. See, it printed out here. So it's checking to see if X exists, here if X is 0. If 0 is gonna go here. But then here is checking to see if X is not 0 in a sense, anything but 0. So you can do that with a value. Like if you had a bank, if you was at a bank and this was amount, all right? And amount just could be the class. Well, I'm gonna just put a value. All right. But if you was reading from a data file and you was reading in the amounts of people like checking account balance, and you check to see if amount, all right? That's asking if a person has an amount, whether it's negative or positive, anything other than 0, then you can do whatever. So you don't have to ask if it's greater than 0. You could just say if amount, all right? Well, and it'll tell you whatever. And then if you do the not amount, that means if it's 0, if the account is 0, then that's what you check in here. If it's not amount, meaning if it's 0. So those are some of the little tricks you can use in C++ dealing with those logical operators. All right. Again, I told you earlier, be careful of the semicolon. If you put a semicolon right after an if statement, now they said error. You saw that what? We didn't get an error. What we got a logical error, but we didn't get any syntax error. You know, it just ran the program, but it didn't run it in the fashion that we wanted it to run. So you got to be mindful about putting semicolons at the end of if statements. And when we get to the next chapter, whiles, loops, and whatnot, the while loop, the for loop, and whatnot. You got to, you got to be mindful for that. The do loop, you're gonna need semicolons in certain places. All right. Okay. And like I say, what I'm talking about when I say use the curly braces, all that's dealing with programming style. You don't have to put the curly braces to open and close the true logic or the false logic or the else logic. But like I said, it's just a programmer style. You know, if that's your style, cool. Notice here what they did though. They did the if logic and they just put the and they had one statement and they just put the default statement on that same line. So rather than have two lines of code here, they just had one line. If A is greater than or equal to 100, I'll put this all on one line, then semicolon. Now, like I say, it's good. It's okay to do it, but if you have some kind of problem here or here, you don't know. You might not know exactly where it is in that line because you got pretty much two lines of code. But to do it, you can do it, no problem. All right. Now I'm talking about comparing floating point. What happened with floating points? It only go to a certain amount of decimals, and eventually a number with a decimal place will be the same value. So you got to watch. So what they did was they showed you in this program. So they got double A is equal to 1.5, double B is equal to 1.5. They added 0.00 to the whatever degree that passed with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, about 16, 17 decimal places. All right. So they added that to it. And then it had if A is equal to B. And look, the output was they are the same because up until a certain point, the computer gonna look at that value as being what? The same value. All right. So what they tell you, what you might need to do is and say, go back to this. Say now that you've gotten a feet in the relational if logic, let's look at the subject true again. All right. So and then let's say to prevent the round off error causing this type of problem, you should stick with greater than or less than. So to avoid this, rather than try to ask if this is equal to this, ask if one is greater than. And that will kind of let you know which one is greater than or less than. But because equal to, they won't go past a certain amount of decimal places, and the number you think is equal is not equal. It's just very, 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 very close to being equal. All right. All right. So now, in this section, you can see that a relational expression has a value either of 0 when it's 1 when it's true and 0 when it's false. Okay. In the world of the if statement, however, the concept of true is expanded, and I showed you that when I said if amount. All right. So that's pretty much where they're going. Okay, but all values other than 0 are considered true, like what I was telling you with amount or whatever. So this means that any value, even a negative number, represents true as long as it is not 0. So what I was showing you here, see, like when I say a not amount, so I could put a negative, well, let's do the positive part. Okay, do the positive part. I'll take this part out. All right. So what happens is if amount, this should hold true. I'm gonna put true here. All right. So this should hold true because what? Amount is a number, but it's a negative number. So when I run it, it's gonna hold true. If amount is gonna yield 1, and it's gonna be true. All right. So see, true. Now, I could put a positive number or just take the negative off. Same thing. It's gonna hold true. All right. We said it's checking to see if it's a number, anything other than 0. So now when I put a not in here, it won't execute it. It's just gonna say program ended because it's gonna return a 0. Well, no, my fault. Not that. Excuse me. But it's looking for 0 for that. So if I go back here and I change this to 0, all of a sudden now, if amount, I'm asking if it's a value, anything other than 0. No, it's not. So now it's going to just print program as ended. Oh, I forgot what I had. See, in the program. So it didn't print out true because it's 0. So that's what and that's what they're talking about in this section. You know, that of value. So look here, value would be a variable. It says see out, it is true. Well, if value, meaning if value is what? Any number other than 0, print out it is true. All right. If x plus y, if the results of x plus y is anything other than 0, print true. So you're saying, well, Mr. Vessel, I'm not sure how you talking about that. So let's look at this. Let's say we make this -3, and we make this 3. All right. Well, let's see. If amount plus y. All right. So amount plus y gives you 0. So it should not print the true. So when we debug this, it's just gonna say end of program. See what I'm saying? Because what? A -3 plus a 3 gives you 0. So it took this, -3 plus 3 is 0. So it says, oh, it yields a 0, so we're gonna do the false. But like I said, we could change this to Z, and Z gonna give us another number. It's gonna be a +15. All right. So now when I run it, it's gonna say true because there's any number other than 0. You understand? So that's what they're saying. And any expression that yields that, sometimes you want to do that, sometimes you may not. All right. So x plus y, what they're saying, evaluate this expression. What is value? If it's any number other than 0, it will output true. All right. The power function. We've used the power function in the last chapter. So all this saying, if the power of a, b, all right, whatever number raised to the b power, if it's positive, true, or not positive, scratch that. If it's any number other than 0, it's going to output true. Again, is it iterating that? Don't get confused with the comparison or the logical comparison equal to the assignment equal. You will run into issues if you do. All right, you got to be aware of that. This compares one variable with another one, or value with another one, and this one assigns the value on the left to a variable to the right. Okay, right here. Now, see how they didn't say error? They say calculation. See, so what happens here, this will assign x to 2 to x every time and make that expression true. So it'll be true every time it executes, no matter what. So if that's the case, why put that in there, right? If you have the double equal, then you're checking to see if x is equal to y without changing what x is, all right? Look here in this program, I'm looking for the if. So here, look at this. This will give everybody a congratulations. That's a perfect score. Because what? Average equal 100. Assigning the value 100 to average. So you understand? That would be wrong. All right. It will not give you the proper results. Everybody in the class will get this output. Congratulations, you have a perfect score. All right. So you gotta be mindful, because if you look at it, if I set amount to equal, I'll say score equal 100, or say 90, say 50, and then we ask, right, and we do something like I'll leave the true part down. All right, and then I'll say congratulations. All right, and you'll see that what? That's very confusing. So we're doing what? Score equal 100. So but score is equal to 50 here. So when we run it, we should not get we shouldn't get true and we shouldn't get congratulations. Gotta rerun it. But look, true congratulations, you have a perfect score. But that's not right. Now, if we do this, put the equal sign, now it won't print anything. It'll say what? End of program. See what I'm saying? So you got to be mindful. Be mindful of that equal sign. All right, be mindful of that. All right. Expanding the if, that's where you use the if, well, with multiple statements. We've done that. Congratulations, that's a high score. You deserve whatever. You have to enclose it or embody it in curly braces. If not, you're going to have a whole lot of logical problems. So if you have more than one statement that you want to associate with an if, you have to enclose it in these curly braces. Got to. So be mindful of that. All right. So it's just saying don't forget the curly braces. Because look, this will say if average is high score, average greater than high score, it'll say congratulations. It'll do that, do that. But if the score is not high, it'll skip the first one, but it'll still say that's a high score. You deserve a pat on the back. So just be mindful. Just be mindful. All right. It's about that time. If else, we did the if else. If this, do this, else. Look at this statement. And see, this is some of what you could have used for that program you did previously. Odd and even. Number modulus 2 equals 0 is even, otherwise it's odd. So that's where that pretty much came from. All right. So what? If number modulus 2 is 0, if it's true, we're doing this. If it's false, we're doing this, and then we continue. So just showing you, you got a path you could follow. If it's true, path you follow. If it's false, and then everything come back to the program and execute of the remainder of the statements in the program. All right. So this is the end of class. So everybody took the test. I'll go ahead on now and extend the assignments right quick. And like I say, you could have, like I say, you could go if you got to go, but let me extend those assignments before I forget. So that's 1, 2, and 3 programs. Oh, it's 4 programs. All right. So I just edit. All right. So I'll just I'll do the change the until date. Leave the due date. So you're gonna see the due date, but the until date gonna be the date gonna allow you to access it. Okay, get this up. 22nd today. 24th. All right. I'm gonna copy this. So you got today and tomorrow. Okay, that's the first one. Okay. There we go. Okay. So yeah. Next. Yeah. And one more. If I get them. All right, so they are all set. And like I say, going on and get that done. Let's see here, modules. For the infologic. All right, so what I'll do, class, I'm gonna open up these programs so you can actually look at them and work on them. And if you got questions, we could talk about it next week, but they'll be due the following week once we complete the chapter, all right? But at least you'll have a chance to look at them and be able to ask questions about them and whatnot. Okay, so
Yes, sir.
everything is set. I'll just set these to 2 weeks from now, so that you can work on them, look at them, ask questions or whatever. So let's see, the 22nd. Okay, be the 8th. All right. So yeah, you'd have those. Okay, copy. Because we got to do the loop. We got to do the for loop. And then we're gonna work on I think it text, some text and some work with files, some data files. We'll look at that. All right. I'm gonna post these so that you can look at the, and next week you come with your questions or whatever. All right. Why didn't it open? Oh, there we go. Yeah. And one more. All right. So anybody with any questions? Any questions? There are no questions. I'll catch y'all on next class period. And like I say, work on those programs. Try to get them right. Okay.
Yes, sir, Professor. Thank you again.
All right. Have a good one. Stay dry. Don't get wet.
Yes, sir. You too.
All right.